Don't forget that you do want to make sure you're doing your notes during class. Remember, if you do your notes after class, right, so notes after class, then you just get notes credit, only notes credit. But if you do your notes during class, then you get both notes credit and attendance credit. So again, if you want attendance credit, you got to be working on the notes during class and passing them, because we give you all the answers, at least enough answers to pass, and so you should be able to pass them. Always, 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 you should pass them. All right, cool. Let's go ahead and thank you, Kamara. I see you in the chat. Beautiful. All right, so let's take a look at what we have up here. So find the light in situations. Yes, so look for the positive parts of difficult situations. Sorry, give me a moment. Learn from our mistakes. I think that's an excellent way to think about it. That sometimes there are negative things that have happened in the past, but we can kind of learn from them and become more positive in the future, or have positive reactions, right? We can't always control our situations. We can't always control other people, but we can try to control ourselves and have positive reactions. Laura, yes, you said focus on the positive instead of the negative outcomes. Clear your mind of negative thoughts. And Marina, help other people. Yeah, sometimes just looking outside of yourself helps you to be more positive, because you're not as focused as what's going on with your own life. You're more focused on, thinking more outwardly, which often helps. Anthony, know your self-worth and move on from toxic relationships. That's an excellent point there, talking about how sometimes there are friendships or relationships that definitely aren't beneficial towards being positive, right? So know you are worthy, and that you can move on from toxic relationships. That's a great one. Don't let anyone tell you you can't do it. Yes, Julie. Yeah, persevere, be resilient, right? You know your own worth. I love all that. We are going to be talking a little bit about positivity and negativity today, albeit in a different kind of way. So let's go ahead and jump into that. This is a reminder, please do not share contact info during classes. Please participate often and well, and behave appropriately. And don't forget that Class Connect sessions are recorded and distributed for learning purposes. We are on day 9 out of 60. This countdown is going to get into the teens pretty soon. Pretty crazy. We are going to start our newest unit talking about the 2A atomic theory and models, and completing the 2A notes. Now, this is a reminder that your Unit 1 food project was technically due yesterday. Don't forget, it is worth over 70% of your grade. It's a huge chunk of your grade, so you really, really, really want to make sure that you are making sure that you are getting that done, because otherwise you're going to see your grade drop quite a bit when we zero it out on Monday. Please remember that projects are not meant to be intimidating, right? Projects are graded on a 5 through 10 scale, which means as long as you try your best on it, the lowest grade you could possibly get on it is a 50%. But by try your best, this means that you can't have any blanks, and that you can't have random answers. It does need to be clear that you actually followed along with the recording while you did recordings. There are 2 for the first project, 1 for the first set of slides, 1 for the second set of slides. It needs to be clear that you watched the recording and you actually did each step, right? So you have to do each step. Again, the recordings have a lot of the answers too, so definitely take a look at it, because it has a ton of the answers that you need for your project. So as long as I see that it's very clear you watched the recording, the lowest grade you could get is a 50%. And honestly, throughout this entire year, every student who has tried hard on a project has gotten an A or a B. So that should be encouraging to you, especially after you do your first project. You will be surprised if you try hard on how well you did on it. Okay, so make sure you just try hard on them. Again, I did mention that technically it was due yesterday at 4 p.m. It will not be zeroed out until Monday though. So feel free to take the weekend to kind of work on it and get it submitted over the weekend. Like Julie says, you're going to work on yours today. That's awesome. Yeah, I'm totally fine with that. I'm pretty flexible with those, because I'm not going to start grading them right away. I'm going to give you guys a little bit of time to make sure they get turned in and that they're done well. I care more about them being done well than them being done in a rush and done poorly. Okay, go ahead and give me a smiley or an emoji in the chat if all of that makes sense. Smiley or an emoji in the chat if all of that makes sense. Perfect. All right. Welcome, Landon. Beautiful. All right, everyone. So we are talking about atomic theory and models today. This is our entire unit all about the atom and the periodic table. So we're jumping into the pretty chemistry heavy stuff now. So we're going to review the difference between matter, elements, and atoms. We'll talk about protons, neutrons, and electrons, which are found in the atom, and the different atomic models and how we got to our current atomic model. And we will be working on the 2A notes, so please get those open. And again, raise your hands if you haven't already. I know many of you have. I remember Kamara, you did raise your hand in the chat. There is supposed to be something on the screen, Marina, so if you don't see it, log out and back in, and that usually fixes the problem. All right, go ahead and raise your hands. We have our notes getting opened. All right, Marina, let me know if the screen was fixed. Make sure you answer question number 1. Again, this idea that if we do our notes during notes after classes, we only get notes credit. But if we do notes during class, we get both notes and attendance credit. Right? So if you want attendance credit, you need to be participating and doing your notes during class. Awesome, Marina. Go ahead and think back to when we were talking about our first lesson where we learned about matter, elements, and atoms, and we learned about how they are kind of like an analogy to a building made of bricks, made of different materials. All right, so let's go ahead on the board. I want you to go ahead and match these up. What is matter more like? What is element more like? And what is an atom more like based on this analogy? Which one is more like a single brick? Which one is like the entire building? And which one is more of a wall of identical bricks made up of the same type of bricks? Go ahead and match those up for me on the board. Use your line tools. Thank you, Jalen. Thank you, Jessica. Thank you, Micah. Excellent, Jalen. Perfect. Love all that participation. Thank you, Ronnie. I see you up there, Marina. Perfect. There are 4 projects. So there is a food project, there is an element project, an amazing reactions project, and a friendship project. So it's a 13-week long trimester, and so you have a project every 2 or 3 weeks that's due, and then just a final exam. Yeah, great question. Awesome. All right, let me go ahead and pause these tools and take a look here. Yeah, I would definitely agree with this. Yes. So matter is, remember, all of the physical substances around us. So that would be more like the entire building in our analogy. An element, again, is made up of many of the same type of atom. So if an atom right here is more like a single brick, then it would make sense that an element is like many of those same bricks. So it's a wall of identical bricks. Excellent job on that. This one is going to be number 2 in your notes. Go ahead and raise your hand when you have number 2 saved.
Atomic theory. Remember, matter is anything that can be made up of atoms, has mass, and takes up volume or space. Elements are what is making up that matter, and elements are made up of several of the same type of atoms. So we'll discuss this a little later, how matter is organized, but anything that you can say, let's say let's say a pure metal like gold, it's all made up of the same atoms that are referred to as gold atoms. An atom is the building block of matter and is the smallest unit of matter that keeps its identity. So like with my gold analogy, if we divide a piece of gold infinitely until the smallest point where it is still considered gold, that unit of matter would be an atom. Anything smaller, and we're going to separate into smaller particles that we will term in later slides. But yeah, trying to split anything smaller than an atom will change its properties. All right, moving on. And then we have this, one of our first funny cartoons for a day. We say that we can never trust an atom because they do make up everything, all right? Even though they are matter and they do make up everything, they're very dishonest about it. So never trust an atom.
Excellent. So taking a look right here, again, matter, again, is everything that is all around us that is physical. Today we are going to be focusing on elements and atoms, though. So remember, elements are a pure substance. They are not a physical combination like a mixture over here, which we learned about in our previous unit. Elements, on the other hand, are physically pure, as well as they cannot chemically be broken down into anything simpler. Remember, Mr. Bangle just said that, for example, hydrogen and oxygen, you try to break them down, you still just have the same hydrogen atoms and the same oxygen atoms because they're only made up of one type of atom. So that brings us to talking about the subatomic particles of atoms. Remember, again, atoms are the smallest complete unit of matter, but they are made up of things that are smaller. Go ahead and tell me in the chat box. We're going to be using this term subatomic particles. Think about the prefix sub like in a submarine. What do you think of when you hear sub? Go ahead and tell me in the chat box. What do you think of when you hear the prefix sub, like in a submarine? Yeah, so you should think of like below or under or down. Yes, perfect. Submerge. Yeah. So when we talk about subatomic particles, specifically, what we're meaning is we're meaning the particles that make up an atom. So they're smaller than the atom. They're actually building the atom. So they're below the complete unit of the atom. Smiley faces or emojis in the chat box if that makes sense. They are less than the atom. Okay, so there are three subatomic particles. There are protons, neutrons, and electrons. We actually already introduced these in Unit 1, but we're going to start going over them more in depth. So protons are the subatomic particle in the center here that is has a positive charge, a positive one charge. The way I remember this is pro again starts with the prefix pro, and like pros and cons, pros, are they the good ones or the bad ones? Are the pros the good ones or the bad ones? If you think about pros and cons, yeah, they're the good ones. So if you think about that, you should always be able to remember that protons are the good ones. They are the positively charged ones. Now, the role of the proton is protons are in charge of identity, which means that if you change the number of protons, you change the identity of the atom. So the number of protons, also known as the atomic number, must always stay the same to keep the identity of the atom the same. We'll be taking a look at the periodic table. On the periodic table, each element has a number at the top called the atomic number. And again, this atomic number is the number of protons. Number of protons. So here, oxygen has 8 protons and must always have 8 protons. If it did not have 8 protons, it wouldn't be oxygen. It would have a different identity. Give me a smiley face or emoji if that makes sense. Again, protons, possibly the most important to the atom in terms of identity. All right, they're the most important in terms of identity. Thank you, Shivani. Thank you, Ronnie. Thank you, Dima. Beautiful, Jessica. Awesome. All right, now protons are found in the nucleus. The nucleus means the center, and everything that is in the nucleus has mass. All right, so our nucleus has mass. So that includes both protons and neutrons. We'll talk about neutrons in a moment, but protons have mass. Specifically, their mass is 1 AMU. AMU stands for atomic mass unit. It's literally the mass of a proton or a neutron. So it's 1, right? Because proton is its own mass. So it's 1 AMU, the mass of the proton. Again, anything in our nucleus has mass. You can see that right here. Our protons are big. They're big and massive. This is going to be number 3. Go ahead and raise your hand when you have number 3 filled in. Fill in the blank with the word identity. Only the word identity. Make sure you spell it correctly. You have 20 seconds on the clock. Go, go, go.
All right, so off to our next subatomic particle, we have the neutrons. Remember, we already explained that neutron is the other particle that is in the nucleus with the protons. What their purpose is that they prevent protons from repelling each other. Because protons are like charges, they like to repel each other as almost as if you ever taken two of the same ends of a magnet and try to put them together, it's almost impossible to keep them together without them pushing each other apart. So just like magnets, protons are always wanting to repel each other because they have that same charge. So that is the purpose that neutrons serve. We say that the charge of the neutron, the reason why they're so good at that job is that they have a neutral or zero charge. And so that's how you can remember that charge is by associating the words neutral with neutron. Neutrons also weigh 1 atomic mass unit, just like protons, so 1 AMU, and they're also found in the center or the nucleus. And if we just take one quick look at the size comparison at the bottom, we can see that neutrons are also about the same size as a proton, so that mass kind of does make sense in that respect. All right, so for number 4, we're going to answer the word repelling as it is spelled right there. We have about 20 seconds.
All right, so taking a look at electrons here, electrons have the negative charge, right? So we've learned like protons, like the good ones, those ones are positive. We have learned that neutrons literally start with the same 5 letters as the word neutral. So the only one left over are the electrons. Those ones have a negative charge or a -1 charge. Now, electrons are a little bit unique. They're not in the nucleus. They're actually found on the outside of their nucleus, and they are very, very, very tiny. So their role is they are in charge of bonding. All right. So essentially, they are like the hands of the atom. So what I want you to imagine is like if you were to try to bond with someone and try to show your affection towards somebody, you wouldn't necessarily like go like ear to ear with that person and try to hold ears with that person because that would be ridiculous walking down the street. Instead, it makes a lot more sense to use a part of your body that's more on the outside of your body and that's smaller for when you want to walk down the street with them. So in the same way, electrons are tiny. They are the hands of the atom, and they are on the outside of the atom. So they are able to bond or connect with other atoms. Give me a smiley face or an emoji in the chat if that makes sense. Again, they're on the outside, they're tiny. They are the hands of the atom. They can hold hands with other atoms. Now, again, I mentioned that they are very tiny. You can see them right here. This is obviously not a real representation just because they're too tiny for us to see in general, but they are so tiny that they actually almost have no mass. So we'll see in later lessons that when we talk about the mass of an entire atom, we actually only care about the protons and the neutrons, again, the stuff in the nucleus. These electrons are too tiny, their mass does not matter. Okay, so their mass does not matter. It's what we call negligible mass, not enough mass to matter. So they're on the outside. Again, they're not in the nucleus. Anything that's in the nucleus has mass. Anything on the outside has no mass. All right, essentially. This is going to be number 5. Go ahead and fill in the blank with the word bonding, only the word bonding, and go ahead and raise your hands. You have 20 seconds. Here's our next comic here. Go ahead and give me a smiley or an emoji once you get it. You can see this one saying stupid electrons, and this guy saying I'm sick of your negativity. Smiley or an emoji once you get the joke. Why is he saying I'm sick of your negativity? Tell me in the chat box. Why does this make sense? Saying I'm sick of your negativity, why does that make sense? Thank you, Jessica, Anthony, Laura. Yeah, exactly, right? Because electrons are negative, right? So we just learned that electrons are the last type of subatomic particle, the one that we don't really have a great way to remember it, but it's the one that's left over, right? So we know that electrons are negatively charged. Excellent. All right, I'm going to go ahead and show a demo with you up on the board just so we can kind of see these particles in action. So let me go ahead and take a look here. So taking a look here, let's go ahead and first take a look at, I'm going to go ahead and open these all up. If you want to play around with this on your own time too, that's totally fine. There's the link to it. But let's go ahead and take a look at what happens when we start adding protons to our atom. So take a look here, all right, our proton, we added it, and now it's actually turned into an actual atom or element, in this case hydrogen. What do you notice happens when I add a new proton? Tell me in the chat box, what do you notice happens when I add a new proton? The third one as well, what do you notice is happening as I add more protons? Yeah, so there's a couple things that are happening. Right, the mass is increasing, right? So we've learned here that mass is related to the stuff in the nucleus. So as I add stuff to the nucleus, I have 3 particles in the nucleus. I now have a mass of 3. We can see that it's getting more unstable because there's nothing to help prevent these protons from repelling. And absolutely, the most important thing here is that the actual element is changing. Remember, protons are in charge of identity. Let me go ahead and see if I can write that note up here. So protons are in charge of identity. Let me know if you can see that note, okay? So yes, we can see that. Now, if I want to make this more stable, remind me in the chat which of my subatomic particles, neutrons or electrons, will help to make this more stable, will help to prevent those protons from repelling. Remember, think about the other subatomic particle that's found in the nucleus. Excellent. I see Landon. I see Laura fixing those mistakes. Go ahead and fix that mistake. Tell me in the chat which one will help make our protons more stable and are also found in the nucleus. No worries. That's what we're learning right now. So that's why we're practicing it. Yeah, neutrons. So let's go ahead and add some neutrons and see what happens. As you notice, as I add neutrons, I'm adding stuff to our nucleus, so I'm getting more mass. So now I have a mass of 4. All right. Now I have a mass of 5. And now I have a mass of 6, and now it's stable. So I have enough neutrons to help keep my protons stable, to help keep them from repelling. All right, now let's go ahead and take a look at what happens when we add electrons. Again, should electrons go in the nucleus or on the outside? Should electrons go in the nucleus or on the outside? Yeah, they should go on the outside. So I'm going to go ahead and add some electrons to the outside. And you'll notice electrons are negatively charged. So now they're actually balancing those positive charges. All right, and so now, as I add more electrons, my charge is getting closer and closer to neutral. So now you can see I now have a neutral atom, A stable atom, it's got the same amount of positives from the protons and negatives from the electrons. All that mass is only coming from the center part, from the nucleus. So things I want you to notice. Again, protons would change identity. Neutrons and protons contribute to mass. Electrons do not have mass. They are found on the, and electrons are on the outside of the atom. Go ahead and give me smiley faces, emojis in the chat box if all of that is beginning to make sense. Actually, there we go. Perfect. Thank you, Kamara. Thank you, Ronnie, Landon, Jessica, Jaylyn. Excellent. Let's go ahead and practice it one more time, just in a different format, so that we're as familiar with this as possible. So let me go ahead and pop this back up on the whiteboard. And let's take a look here. So again, what are protons in charge of? Go ahead and tell me in the chat box, what is the role of the proton? Starts with the letter I. Starts with the letter I. Go ahead and tell me in the chat. Again, protons, as I added protons, it went from hydrogen to helium to lithium. So what was the proton in charge of? Yeah, it was in charge of identity. And why did we add neutrons? We added neutrons to make the atom more what? Think about how those protons were kind of freaking out in the center until we added neutrons. Yeah, it made it more stable. So neutrons are in charge of stability. Keep these in mind because you're going to need this for your next check for understanding, the next question you have to do on your own. So keep these in mind, okay? Now, protons we know are positively charged because they have that pro, meaning good, so those ones are the positive ones. What about neutrons? Tell me in the chat box, think about that prefix there, neutron, N-U-E-T-R. What kind of charge do neutrons have? Right, protons have a positive one charge. Neutrons, yeah, they have the same 5 letters as the word neutral, or zero, zero charge. Excellent. What about electrons? They're the ones left over. All right, we've got positive protons, neutral neutrons. What do you think electrons must be if they are the ones left over? They're the ones left over. We still need something to balance off the positives. Something to balance off the positives. Yeah, electrons, therefore, are negative. All good, Tima. Yeah, that's why we're practicing. I know, it's a lot to remember about 3 different particles. I gotcha. Yeah, these ones will be the negative ones. Great. Now, let's go ahead. We'll talk about mass in just a moment, but let's actually first talk about location. Which 2 particles are found in the nucleus? Which 2 particles are found in the nucleus? Yeah, protons and neutrons, right? Remember, so these ones are in the center, they are in the nucleus, and everything in the nucleus must have mass. I already have that neutrons have a mass of 1 AMU. So what mass do you think protons should also have if they are also found in the nucleus? Remember, everything in the nucleus has mass. So if neutrons have a mass of 1 AMU, what do you think the mass of a proton is? Excellent. I see Micah. I see Laura. Let's get some more answers in the chat. Everything in the nucleus, yeah, they all weigh 1 AMU each. So 1 AMU for a proton, 1 AMU for an electron. And electrons are not found in the center. They are actually orbiting on the outside of our nucleus, and therefore they have how much mass? Again, if you're not in the nucleus, you basically have how much mass? Yeah, you basically have 0. So they are approximately 0 AMUs. Excellent job on this one. This one you are going to go ahead and answer in your notes now. Believe it or not, all of the answers are actually in your notes 3 through 5. So if you do need help, refer back to notes 3 through 5. You have 45 seconds to work on number 6 and raise your hand. Go, go, go.
Particularly look like? Well, at first we didn't really understand them. At first, there was this scientist named Thomson in 1904. Just as a reminder, you're not going to have to memorize any of these names and dates. We're just using them for reference. But in 1904, he theorized that the atom was composed of a solid positive sphere with negative electrons dotted throughout that sphere. And he named this or termed this the plum pudding or the raisin bread model. And we can see that in a sphere shape, that is what raisin bread would look like, and we can see that it kind of resembles that shape and pattern. So go ahead for number 7, mark down sphere. Learning about atomic models. So later on, in about the year 1911, Rutherford thought that his theory was that the atom was a big solid mass called the nucleus, located in the center, and that orbiting that center was a spread of electrons that were orbiting in no particular way, but just all in the same sphere around this center nucleus. He confirmed this somehow by constructing an experiment involving gold foil, where he shot radiation through a thin gold foil sheet and discovered that most of the rays bounced back, but most of the rays actually went through, confirming at least that the atom was mostly comprised of empty space, with some dense centers sparsely distributed throughout. So for number 8, we're going to write nucleus as it is written right here. So one more model before we get to the most recent one, but the second most recent model is called the Bohr model. It involves actually two scientists cooperating together. In 1913, the scientist named Bohr theorized that electrons are not actually in a random arrangement, and they're not inside the atom. They're actually traveling in shells that orbit at specific distances from the nucleus, kind of like a solar system, if you want to think about it that way. All right. The more outer the shell is, the more electrons it can hold. And as a side note, then in 1932, Chadwick, another scientist, discovered that the nucleus contained both positive protons and neutral neutrons, as we've already learned. But that's who kind of confirmed that concept. All right. So for number 9, we're going to mark electrons. We're going to write electrons for number 9. One last funny cartoon for us. Think like a proton, all right? All right, okay, guys? Always think like a proton, because that is how you stay positive. All right, picking it up with our last atomic model for the day.
Excellent. So our last atomic model is the most recent version. This one is called the electron cloud model, or the Schrodinger model. So this one actually looks kind of crazy. It shows kind of a fuzzy path of where electrons most likely have been. This is not actually showing each of the electrons. In fact, the reason that we use the Bohr model more often in class is because the Bohr model is a lot easier to take a look at and understand in class. But really, this is a much more accurate model. The reason being that based on the Heisenberg uncertainty principle, Schrodinger stated that it's impossible to know exactly where an electron is, as well as the motion of the electron. That is the Heisenberg uncertainty principle, that it's impossible to know both things about an electron. And so the result is we can only calculate the probability of where those electrons most likely are, and showing those probabilities gives you kind of this fuzzy path. That fuzzy path, interestingly enough, does kind of line up with a lot of Bohr's simpler models, but again, this is just going to be a more accurate representation. This is number 10. Fill in the blank with the word fuzzy, only the word fuzzy. You have 20 seconds. Let me know if you need help. Otherwise, raise your hands. Raise your hands. All right, awesome, Mary. Go ahead and submit that. Let me know in the chat box, how did you do? Let us know if you got A's and B's. We want to shout you out. We talked about protons, neutrons, and electrons and the different atomic models today. Awesome, Jalen. Awesome, Marina and Dima. Jessica, Narish, great job, everybody. We're going to go ahead and just wrap up right now because we are out of time. Make sure you submit that. Make sure you passed it so we can also give you your attendance. Remember, do your notes during class to get both notes credit and attendance credit. Thank you so much, everyone. We will see you later. Go ahead and take 30 seconds to log on out. Yes, no problem, Thalia. Stick around for a moment and we will help you out with that. Bye, everybody. Thank you so much.